Welcome to our second episode on building a constant pressure pumping system using the GK3000 upgraded VFD from ATO. This time, our setup includes a separate, external 24-volt DC switching power supply specifically used to power the level sensor, which is the key difference from the previous version. Here are the essential components you'll need. Our control brain, the upgraded GK3000 variable frequency drive, a 2-wire 420 mA submersible level sensor, a self-hold push button for control, a 3-phase induction motor, plus the key differentiator for this build, a dedicated 24-volt DC switching power supply. All these components are available on ato.com. Links are in the description. The key control logic is as follows. The 24-volt external power supply is used to power the sensor and the VFD control inputs. The self-hold push button manages VFD constant pressure on-off. The VFD adjusts pump motor speed based on the 4 to 20 mA sensor signal to regulate water pressure. Now let's move to the detailed wiring. We'll break this down into 3 logical sections. Number 1, power connection. L and N wires supply power to the VFD with proper grounding of the PE terminal. Number 2, motor connection. Motor phases U, V, and W link to the VFD. Number 3, level sensor integration. This is the most critical part. Since we are powering the sensor externally, you must remove the factory-installed jumper link between the 24-volt and OP terminals. This step is mandatory, as it prevents the VFD's internal 24-volt output from interfering with the external power supply. Now let's make the connections. Connect the supply 24-volt output to the VFD OP terminal and to the sensor red wire. Connect the supply 0-volt terminal to the VFD's GND terminal. Short GND to COM to unify the reference ground for input signals. Set the analog input jumper to CI to I to select 4 to 20 mA current input. Connect the sensor's green wire to the CI terminal on the VFD. This allows the VFD to read the sensor signal correctly. Finally, connect the self-hold push button between X1 and COM on the VFD. Your physical wiring is now complete. Now let's configure the GK3000 VFD step by step. Navigate the GK3000 menu in the order below. Press menu and enter parameter group P0. Enter P0.01 and set it to 10 to enable constant pressure mode. Move to P0.03 and set it to 1 to accept run commands from terminal input. Navigate to group P6. Find P6.02. Set it to 1. So the VFD uses CI terminal as the PID feedback source. Next, find P6.06, the proportional gain. Set this to 0.01 for quicker response. Still in group P6, locate P6.30 and enter your desired pressure value. Like 0.07 in megapascals. The system will work to maintain that target. To define the safe adjustment range, set P6.31 to 1 to define the maximum pressure limit, and set P6.32 to 0.005 to define the minimum limit. Now configure sleep and wake logic. Enter P6.35 and set it to 0.8. This is the wake level at 80% of the set pressure. P6.36 is the wake delay. Set it to 2 seconds. For the sleep function, find P6.37 and set it to 1 or 100% of the set point. P6.38 is the sleep delay. Set it to 5 seconds. Finally, enter P6.41 and set it to 11 to activate this logic based on pressure percentage. Programming is done. Important note, after setting all parameters, if you go back and confirm P0.01 to 10, the VFD may auto-reset P6.30 to a default like 0.5. Simply re-enter your desired value, like 0.07. Now that everything is set, let's see the system in action. Navigate to monitor parameter B0.46. This shows the target pressure. Navigate to B0.47. This shows the real-time feedback pressure from our sensor. At this point, you can adjust the target pressure live, using the up-down keys within the set limits. Press the self-hold button to start constant pressure mode. The VFD will ramp up the motor. When the feedback pressure reaches 100% of the set point and holds for 5 seconds, the VFD automatically enters sleep mode and stops the motor to conserve energy. While in sleep, you can confirm the real-time pressure in B0.47. When the pressure drops to 80% of target and stays there for 2 seconds, the VFD automatically wakes up and restarts the motor to boost pressure back. When pressure again reaches 100% and remains at or above that for 5 seconds, the system returns to sleep mode. The system is now in standby, ready to wake automatically when needed again. This completes the basic operating cycle of the constant pressure control system. This cycle maintains steady pressure while optimizing power consumption and pump lifespan. Ready to build your own? Every component you saw today, the GK3000 VFD, the submersible sensor, the pump motor, the power supply, and more, is available for purchase right now on ATO.com. ATO is a one-stop industrial automation shop offering direct manufacturer pricing and free technical support. Our engineers can help you choose products, guide you through wiring, and assist with commissioning. Explore detailed specs and shop our vast range of industrial automation solutions via the links in the description below. If this tutorial was helpful, please give it a thumbs up. It really supports the channel. Share it with a colleague who might need it. Subscribe to ATO Automation for more in-depth guides like this. And leave a comment below with any questions or requests for quotes for other ATO products. We read every comment and will do our best to help. Thank you for watching. And remember, for reliable industrial automation components, choose ATO.